welcome. We have been looking forward to doing some information sessions, webinars. Yes, this is live and being recorded. So when we're all done this, we'll figure out how to get it on the YouTube channel to relive this presentation. At the end, there's going to be some links as well. You can download some resources, and there should be a PDF copy of this presentation as well. Right. Our service manager, Jeff Hopper, was planning a stand-up routine to warm up my audience here. Fortunately, he's lost his voice. So you're stuck with just me and the dry technical delivery here. So yeah, we've been wanting to host these information sessions for a long time. Informally, we've done a lot of this as part of some of the virtual training we've provided with various upgrades and renovations with new technologies. Sometimes the on-site training is good to start, and then it's nice to have little training touches as time goes on, especially with some of the very modern systems that have remote access and connectivity features. So doing the remote follow-up training can help. Hopefully the audio works here for everybody. Do most people hear me? All right. Perfect, thank you. It's worried me for a second. I can talk louder, I can throw in a mic as well. But if I need to talk louder, yeah, just throw it in the chats there. I'll do my best to be very audible here. And I was playing around with my mic settings. Okay. All right, I'm not going to touch anything. There might be a transcript with the recording according to the settings I've enabled. So yeah, slides are going to be great. Okay. Yeah, so yeah, we've been wanting to do this for a long time. More recently, we've had a lot of recurring questions related to things going wrong with chemical treatment systems. And, it's not the kind of thing, unfortunately, that's unheard of in the pool world. It does happen every year or two. It seems like there's a significant event where unfortunately there's some harm done, and yeah, dangerous situations that require hazmat response, and yeah, so we're not going to really get into any specific occurrences or potentially some that are under investigation right now, but it's just a good opportunity to review what everyone should know. There's a lot that goes on, and every chemical control system has its own quirks and works a little differently. So we're going to have some general discussion and get into some of the details. And if you guys want me to give a little more backstory on anything, I can address it here or do some follow-up afterwards. So yeah, thanks for attending. So yeah, chemicals and pools, there is an inherent level of danger that I think pool operators are fairly familiar with. It's part of pool operator training. That's along with WMIS and just general chemical handling, is that yes, there's going to be chemicals. So you have to deal with these concentrated chemicals on a daily basis. It might be facility staff offloading a delivery truck. They might actually be using the chemicals. So yeah, safe work practices, training, PPE, all addresses that risk. So people working in the pool, anyone delivering chemicals or shipping chemicals, hauling chemicals, there's risks along the whole line. including where as the chemicals going into the pool, and then the effect of the bathers as well. So all those risk factors are there, and for the most part, they're the sorry, I'm just trying to click out of a couple side screens popping up here. Yeah, terrible multitasker. So yes, the risk of handling chemicals in regular duties is fairly well addressed on that side, which is mostly an occupational safety concern and also related to transportation of dangerous goods. So yeah, there's those isolated risks associated with certain chemicals. So some chemicals might have fuming properties like hydrochloric acid, where you open a jug and the fumes are very aggressive and destructive to anything in the room, including your lungs. But there's PPE for that. Granular powder chemicals can be a respiratory hazard as well. But the more significant risk is when there's unintended mixing of chemicals. So, you can have, there's a whole range of possibilities, but at a lower level, you can have something as simple as maybe a chemical mixing pail wasn't rinsed out. There's some chlorine residue, and then someone goes to use it to, hand feed some acid, and then yeah, there's some noticeable fumes, but they dissipate rather quickly, especially if there's some water involved with the dilution of chemical. But that kind of occurrence can happen, and it's unfortunately a little bit of an awareness thing. But most of the time, if that happens, their PPE is already on, you're protected, and you carry on with your work and maybe learn a lesson. On the other side, though, there's more immediate dangers to health with larger scale reactions. So this would be, you have a large holding tank of chlorine or acid, and the wrong chemical is added to the wrong tank. Then you'll get a very instantaneous reaction that typically affects the staff who are handling it. Hopefully they've already got enough PPE on to keep them safe or at least reduce the harm. But the magnitude of that depends on how strong a chemical is and how much is added. So, on one level, you can have it affect the staff member. It's more localized, but there's also been occurrences where the incorrect mixing of chemicals in the wrong tank or labeling issue has resulted in the need to evacuate a building, where the gas that forms out of that becomes very apparent in adjacent rooms, and is cause for some concern. Sorry, I've got a couple of messages that I have to. Couple people not getting in because of a password. Stand by here. All right, I think I got them figured out. All right, back to the program. Yes, pools are dangerous. So yeah, the results are often pretty significant. And, as a professional pool boy, I do collect some of these news articles, and there's not always a lot of follow-up information. Sometimes it just says there was a mechanical failure or a handling incident or mixing issue. But yeah, the specifics are usually buried in. And but yeah, these are a few examples of where there was a lot of people affected, primarily guests. lawsuits as well. Texas in 2021, that was a big one, 60 people. Sometimes the headlines, like the one on the top right, says London Olympic Center, chlorine gas leak. Well, it's interesting because that facility doesn't have chlorine gas. That was a delivery truck that dumped acid from a bulk container through a fill line that went into the chlorine tank, and it was because I believe is because of a hose color discrepancy where they were used to a certain hose on a certain chemical and not reading the actual label on the tank. So yeah, pretty scary stuff. So it does come down to balancing risk factors. Chlorine is a valuable ally for risk management when it comes to pathogens in the water and handling the microorganisms that can inherit the water. But that, of course, has to be balanced. There's long-term exposure risks related to chlorination, not so much the chlorine itself, but the byproducts. So that's been an interesting and an evolving area in the pool world. We're learning more about what's gassing off from the pool. There's a really good YouTube video I've shown lots of you on the topic. A famous experiment on the pool smell. And spoiler alert, it's not chlorine, it's chlorine plus the bather waste that is really the chlorine smell, which is trichloramine. So there's long-term exposure risks to that. Usually the levels aren't high enough that it's immediately offensive, but there are lots of things and complications with the pool system that can lead to trichloramine being an issue for staff and patrons. The higher the levels, then the more guests tend to be affected. At moderate levels, trichloramine is something that over the course of several hours leads to irritable respiratory irritation symptoms. And then it's usually the lifeguards who are breathing that air all day, every day for years and years that there's long-term risk from that. So definitely an evolving area, but that's not really the focus today, although it is an interesting topic. The immediate exposure risk is usually associated with chlorine gas. So it's a quick reaction, very immediately formed. There's not a lot of warning. There's been talk, clients have asked about detection systems for this kind of event, and the reality is when it's bad, when there's an instantaneous high volume chlorine gas discharge, an alarm system is probably not going to give you much more warning than the people in the pool who are going to feel the effects. Alarm system has some value. I know of one project where there's a chlorine gas detection system in the chemical room. So if there was to be several things going wrong and chemical spillage reacted on the floor and gas was forming with no one around, then yes, a chlorine gas detector has some use alerting that, as opposed to someone opening a door and getting hit with a cloud of green gas. And then in extreme cases, trichloramine can accumulate, and at high levels, that can have some more immediate effects. So if we're to look at the broad picture of how these things happen, what can go wrong, to really generalize here, we've got mixing incidences due to reaction between two different chemicals. So chlorine and acid really steals the show here. That's the bad one, although it doesn't have to be chlorine and acid. There's lots of incompatible chemicals out there, but every chemical has its own danger category. Even within chlorines, you've got stabilized chlorine and unstabilized chlorine. So you actually mix chlorines and have an explosive reaction. So a trichlor puck and a calcium hypochlorite puck are very incompatible. But yes, for the most part, its pools have high volumes of chlorine and high volumes of acid. You pump them into the pool. As long as water's moving and dosing is at the proper level, everyone's happy and the bacteria gets killed without the people getting hurt. But yeah, so these mixing issues could be a labeling problem, delivery or transfer error. So if the wrong chemical pail gets picked or shipped or offloaded off a truck, and the labels aren't distinct enough, that those mix-ups can happen with a bit of complacency and not having a good safety program or checklist in place. And then hand mixing on deck. So that's those cases where chemicals added directly to a pool in response to some kind of contamination, code brown. So you've got your mixing pail out, and maybe someone quickly mixed something that wasn't intended for that pail and didn't get rinsed out. So you can have some contact there. And yeah, so hopefully most chemical additions, you're using water, supposed to straight chemical, so that would mitigate that, the severity of the reaction. Those are fairly immediate reactions, and it's usually the staff that get affected. The other one, so the other category of a mixing incident would be related to, I've called it failure of a containment system. So you've got some way chemical is moving through the lines. So you've got your tank, your pump into the pool line. So if a dosing pump develops a leak, so chemical pump leaks, not uncommon for pools. It's not crazy to walk into a pool mechanic room and see a leak somewhere, whether it's water or chemical. The problem would be if you have simultaneous leaks in close proximity, you will get some bad things forming there. So if you have chlorine and acid pumps really close together, or if they're sharing a containment tray, that's pretty sketchy, where, yeah, you're going to catch and have a little reaction going on. So yeah, two different lines leaking at the same time in close proximity, scary stuff. The tank becomes compromised, so leaking on a tank and no containment. Sometimes there's formed segregation, so like a concrete curb to contain chemicals, and believe it or not, leaking acid actually destroys concrete quite quickly. So a containment curb for acid especially will need some kind of a upkeep if there's been an acid spill. So should you have some type of epoxy or thermoplastic coating to prevent the destruction of concrete and then leaking into places it's not supposed to be. And then failure of pressure tubing. So that the small diameter tubing, so like 1/4 inch, 3/8, that's coming off a chemical pump, goes into the circulation line. That stuff has a fixed lifespan. 1 to 2 years is a pretty good run on chemical tubing, especially if it's concentrated chlorine or acid. Polyethylene's pretty reliable that way. You can go with Teflon tubing, a few bucks more per foot, but longevity might prevail. Hopefully, chemical lines aren't crazy extensive. That adds to the risk factor. The longer your tube's running, if it's going through different rooms before it gets to where it needs to be, that's a situation you want to avoid. So for design and planning, the best way to handle that is to have pool water circulating through the chemical room and having short runs for your dosing pumps, and avoiding the long runs of chemical, especially if you have a chlorine line and acid line running out of one room, showing up in another room. And as the pumps are moving, it can be abrasion against pipe hangers that are holding the tubing, and then you can get leaks developing. So preventive maintenance, changing out the chemical lines every 1 to 2 years is a good idea. For chlorine injection fittings, blockages can build up. Some injectors are more prone to it than others. Ideally, you want to be injecting into the water flow. If you have a situation where chemical injector is recessed back in a line, blockages are going to be more common. As a chemical injector blocks, the line pressure increases and you can more likely to get a rupture there. So with a complete blockage, eventually something is going to give. And yeah, it can be a messy situation. And then dosing pumps themselves, peristaltic pumps with a wearable tube on the inside, those tubes will rupture. A lot of pumps don't have a failsafe. Some do, where if there's liquid detected in the pump head, it'll disable the pump from running. So kind of limit how much chemicals being spilled onto the floor as it keeps trying to pump. But yeah, a lot of that is really proactive and planning. The last one here, unintended circulation on the mixing. So this is the real big one. And we look back at some of these scary stories. People in the pool unexpectedly getting hit with a dangerous gas very quickly. Little speculation on my part, but that's usually the mechanism is chlorine and acid are feeding into the pool piping, but there's no water flow. And then either the reaction becomes big enough that it ends up in the pool, or it's settled in the line, it's creating gas in your piping, and then the flow resumes. So maybe the pump was off, some service was going on, pump got replaced, chemicals are dosing the whole time, pump goes back on, and then that chlorine gas gets shot into the pool. So in terms of controlling these mechanisms, staff training, written procedures, checklist labels is that good first barrier to have in terms of preventing a direct mixing issue. Containment system is really engineering control, so good design. Having good containment of all the chemical dosing equipment. So I've seen lots where a chemical tank might be double walled or have a containment platform, which is great for the tank. In my experience, I don't see a lot of tanks leaking though. It's always the pump and the lines or the injector. So trying to have as much of that as possible in some contained area is a huge advantage for preventing the magnitude of a problem when it does go wrong. And then having good functional checks and written procedures. So we'll dig a little more into that in a few slides. I've been ignoring the chat. Thank you guys. There's a hand raise feature too. Yeah. Everyone's just absorbing everything. But yes, feel free to chat away. Awesome. And then, yes, who gets affected? Staff, usually staff, but if it's really bad, it's the swimmers. We talked a little bit about how the mechanism there of chlorine and acid mixing in the pool plumbing. So I stole these really good images from one of my favorite pool safety videos. I've got quite the collection of pool videos I like to watch. This is one of my favorites. So yeah, the PHTA has this pool interlock safety video. Link will be at the end. It should just be part of every pool operator course. But yes, the first slide there shows normal circulation, chlorine's going in, acid's going in, water's carrying it. All's good. That's working as intended. Number 2 there shows the water flow stopped. So chlorine and acid are just pumping away into the pipe. And then we basically you had our little chlorine gas reactor happening, and then that's just building up in the pipes, eventually trickling out. Or if this was happening and just someone turned off a circulation pump, the pump was getting swapped out for maintenance or replacement, and then pump goes back on, along with the chlorine gas, and that's that instantaneous release. It's not a gradual gassing off, but yeah, pretty spontaneous event. And then the risk of this, comes down to a few factors. The way this is primarily avoided is with some kind of a flow switch. So if flow stops, so slide 2 here, that should stop the chemicals from going into the pipe. That would be a good thing to have happen every time reliably, and I think it does for the most part. That's a very common feature. I don't think there's any controller in the market that I see on a regular basis that doesn't have a flow switch. There are some that are very easy. It's easy to bypass the flow switch because there are definitely times where that flow switch is sensitive. If depending on how a pool is plumbed, where the dosing sample lines are running, sometimes they're sensitive and you get these no flow conditions. And then I have seen where controllers are jumpered a flow switch to keep it running, or the other thing is if the flow cell doesn't have a good strainer on it. So ideally the sample water is before the filter, and then you'll get some sediment and dirt that can plug up a flow switch and stop it from closing or opening, depending on how it's set up. So yeah, the controller itself, in fact, we got a few slides on that, but in general, this is a schematic I stole from my colleague Andrew Gaffey from Pool Operators Club. So this is a good schematic if you're not familiar or hands-on with pools every day. This shows the old pool basin. Your pool here. In this example, pool water flows into a balance or surge tank. It's being pumped out, filtered, heated, and chemically treated. So most controllers have this sample line flow switch, number 2 here. So you can see off the main line, so you got this big pipe carrying all your water to be filtered, and then there's a little trickle that goes through some tubing to the controller where the sensors are. So it goes through the controller, and if flow stops through that sample line, it should stop chemicals from feeding. So that flow switch is a primary mechanism. In Alberta, it's in our building code. It's a requirement that flow stops, or chemical dosing stops when flow stops. That has to be a feature on your chemical controller. Another, I guess, fundamental fail-safe that could be added, although this is not as common, is you can have an electrical interlock. So that would be if the circulation pump is switched off, that also switches off your chemical dosing equipment, just through electrical supply. So a little electrical handiwork, give you a little extra barrier for protection there. So any of that, if you have that and it's functional, that stops this from happening. So to add another layer on that, so you can have this, you can have it functional. There's still a chance that you can have chemical feed when there's no flow through the return line. So what we see here, again, this could be a function of where's the equipment relative to the pool level. So if all your equipment's above the water level versus under the water. You can have some different dynamics where gravity, water flow through your controller could make it seem like there's flow. There's enough water moving that the flow switch is closed and the system thinks there's flow, but there's actually no water returning to the pool. So that's one potential way that even with this functional basic flow switch that's on every controller, you can solve a problem. The other one would be if you're backwashing filters, or your filters have a bump cycle. In those cases, you can have water moving through part of the system. So a backwash, your water's still coming from the pool, going through the filter, but then getting dumped down a waistline or a backwash holding tank. Or probably if a filter's being bumped, I believe that might interrupt the flow circuit somewhat. So in those cases, you still have stagnant areas here because all the water is going into the filter and it can be recirculating around the filter but not returning to the pool. And then you still have chemical going into the pipe. So that's another situation where the flow switch would show flow before the filter, but there's actually no flow after the filter where the chemicals are going in. So that's why best practice is to have a return line flow switch or secondary flow switch. Not all chemical controllers have this. In my experience, some of the controllers we bring in from that are German or the UK in origin, they do have this built in, is there's a secondary flow switch. Looking here for a question. Mr. John Duker of Automated Aquatics. Honored to have you here, my friend. The question is, can some feed equipment siphon without the controller calling to feed? Yes, that's a great question. It wasn't planted, but I do actually have a slide on this. But yes, a siphoning issue is another way you can have a lot of chemical go into the pipe all at once without any circulation flow. It's pretty dangerous stuff. I, early on in my pool career, before I was a pool man, I was just a pool boy, I did know of a gas chlorine pool that had an incident in Alberta where a circulation pump seized or failed unexpectedly, and chlorine gas continued to get pulled into the line because it was injecting at a higher elevation. And then all that water drained out into the pool and pulled gas with it. So, but yeah, we'll get into that in a little bit here. But yeah, the secondary flow switch I think is just a really good idea. We talked a little bit about the sample location. So for a chemical controller to do the best job with the most accurate readings, it should be between the pump and the filter. We find that when you sample after the filter, although you don't have to strain as much out to protect the controller sensors, you tend to have a falsely low chlorine reading relative to what's in the pool. So the filters themselves, regardless of the type of filter, becomes a source of chlorine demand over time. So filters become heavily contaminated bacteriologically, and your chlorine going through the filter changes. So usually the chlorine after your filter is very low, and if that's the sample reference point, it's going to constantly overfeed chlorine in the basin. The basin's always going to test higher because it's trying to jack the chlorine up to a level that's higher out of the filter. And so for that to happen, it has to be even higher before the filter. So we try not to take water after the filter. And in some cases, we also needed a sample circulating pump. So we have an independent pump that's pulling water on the small line just to supply the chemical controller. In some countries, it's more common to actually have a pump pulling water from a wall fitting in the pool basin and to circulate that as a sample pump to try to be a little more representative versus what is going through the pool circulation system. It does complicate your pool design a little bit. You have this other little accessory pump. But that's another situation where this accessory pump is continually feeding water into your controller. But if your main circulation pump, where the chemicals are dosing, is not running and chemicals are feeding, you're going to have another wave of achieving this chlorine gas reaction. So in those cases, especially with the independent sample circulating pump, it's absolutely essential to have a secondary flow switch on the return line. All right. So we talked a little bit about some procedural things it can address. So Andrew Gaffey of the Pool Operators Club has some really good resources. So I have download links in the presentation, and he was very willing to share this, and just to give him full credit. So these are some general risk management procedure and checklist ideas, but site-specific risks should be carefully addressed. There's just so many different factors with pools. Part of it is what chemicals are you using? What's the capacity of the chemical feeder? That's a big one. So the strength of the chemical, is your acid full strength or does it get diluted down? The form of chlorine, and just, yeah, how big is the feeder and how fast can it deliver chemical into the pool? When you crunch the numbers on how many grams per hour a given chlorinator can add, you see quite a range. That it also explains some of the nuances we see with pools as to, why some pools have bigger ranges of chemical readings during operation. But there are some good design practices to follow in terms of what should a given chlorinator capacity be for a volume of water, but also its flow rate and its intended use. So that would be a whole other presentation. Don't get me started on that now. So yeah, these are great resources you can download. The circulation restart procedure, that's specific to reduce the amplification of this problem that we talked about, where the gas chlorine is lingering in the pipes and then the pump goes on, all that water pushes the gas into the pool that hits all the bathers at once. So that's the intention of this circulation restart procedure, is go through the flow chart here to determine if it's safe to turn your pump on after it's been off. And actually, there is a good step in there, John, to your question, is could chemicals have siphoned in? So if you have chemical tanks on an upper level, your pool's lower, there's a much higher risk of that. Other conditions, like how big is the pipe and is there a big vertical drop before it goes back to the pool? So that vertical drop has an impact on the siphoning potential to suck chemical into the lines. But one of the steps here Andrew had is that to be regularly and diligently marking down what level your chemical tanks are at. And as part of this restart is you go back and you make sure your tank hasn't dropped from your previous check-in that day. So if your tank has dropped substantially after a pump has been turned down, that's actually a sign that you should not restart your circulation system, because some chemical has been pulled into the line to balance out a vacuum created. So the restart procedure is super, it's a really good resource just for awareness training. I think there's a lot of, even myself, 100%, I often will have a pump off and not even think about it when I turn it back on. So helping someone with a backwash or training on a new system, this is a really good awareness piece that things can happen while the pump's off that you're not aware of. The next one here, a very general pool chemical safety checklist. It's very comprehensive, covers an array of chemical scenarios at different types of pools. But yeah, great chart that could be adapted and potentially help you to have a safer work practice for your facility. So here's an example of what I call a higher risk containment issue. So you've got lots of dosing lines running overhead. Some are acid, some are chlorine. Bonus points if they're color coded. But these are some cases here where you got pails under these chemicals collecting the leaks. You have a chlorine pail in one area, acid pail in the other. Both pails knock over. You've got your chlorine gas factory up and running. And just having chemical dosing really close together, especially on a vertical pipe going up, one chemical is going to leak onto the other injector. That's scary stuff. In the UK, Andrew Gaffey there, he promotes having 10 times the pipe diameter for spacing between chemicals. So it's not always realistic or practical for existing pools. But yeah, ideally, if you're planning a reno or new pool, it's definitely worth having that on the board. Is say let's get water to our chemicals. Let's not move chemicals long distances to the water. So having a little booster pump running, having a sample line circulating to get the chemical is definitely ideal. Oh, hey Jim, looking forward to chatting with you. So the risk factors that kind of contribute to developing a site-specific checklist or procedure. It does involve the strength of the chemical you're using, pool volume and flow rate, the type of chemical controller, features that controller has, the programming, which we'll get into, and then the chemical injection point relative to the water level. That's your siphoning risk. And then the type of feeder. So positive displacement, chemical feeders that are using pressure to push chemical into a line relative to a venturi. So there's chemical feeders that are intended to siphon and pull chemical into the line. So pros and cons. A venturi system is very safe in that if there's any breakage of a dosing line, it's just going to suck air into the system instead of chemical. Inline generation. So one of the safest ways of chlorinating is to make your own chlorine on demand. There's a couple different ways of doing that. If you have an inline saltwater chlorination system, well, then your resource is salt. You add to the water, and chlorine is generated in the water supply. So it's really hard to have an acid mixing incident if you are chlorinating with saltwater cells. If you have an offline chlorine generation system, so you're using an exterior salt supply for generating to make a chlorine solution tank. It's a lower strength chlorine tank that staff are not having to be hands-on in mixing. So your generator fills your tank and that tank doses into the pool. So yes, you still have a liquid chlorine. It's much lower strength and more neutral relative to any other form of chlorine. But there's no handling of raw product in pails. You might still use acid. But you can mitigate that risk further, especially if you have like a tablet type acid system and there's, you're adding a dry product to a tank. There's no mixing. So lots of variables to consider. Safety should be, one of the number one factors, not just the simplicity or the expense of the chemical. So all in the news stories I shared, they're predominantly pools that use sodium hypochlorite as a chlorine and hydrochloric acid to correct the high pH of that chlorine, right? So the sodium hypochlorite has a pH of 13. So you need a lot of acid to bring that down. And, if you can make different decisions, more stronger, more neutral chlorine sources, that lowers your risk factor substantially. So if we were to look at fine tuning your risk factors in terms of the chemical selection and the type of feeder, for the most part, those are fixed factors with a pool. You have what you have, unless you're going into a big renovation. But where you have some ability to fine tune things and make them safer and add some sensitivity for fail safes is on your chemical controller flow switch interlock. You can have a function check. So if you have it as a standing maintenance task, every time you're doing a weekly backwash, well, when you turn off the pump, if your pump gets turned off for a backwash, if not, plan for a pump stop to clean the strainer, and at that time, just make sure that and check off on the box that yes, your controller acknowledged there's a no flow and it stopped the chemical feed. So a functional check at least once a week. Chemical controller overfeed alerts. So that's really depends on the controller. We'll look at a few common ones in a couple slides. There's every controller is a little different that way. So an overfeed alert is user programmed, and that's a sensitivity. It's usually a time-based setting where if chemicals are dosing for such a period of time and there isn't a significant change, then it goes into an alert mode that stops chemical feeding. And then the other one is a measured value alert. So that's if chemicals are going out of an unexpected range, to have another failsafe where it just stops feeding because things are too off, there's a problem. So that would be the case if a flow switch was jammed. So if there was no flow moving through the system, but a flow switch got jammed up and it was making contact, what's going to happen is that water sample, usually something like the chlorine will actually be dropping, the pH will be going up, not representative of what's going on in the pool. So that quick change with the chemical levels could alert you. But the most practical one I find is that overfeed alert. And a lot of times I see that gets disabled because of nuisance tripping, or someone just doesn't know where to set it. Part of it is a bit of guess and check. So we have some guidelines for setting overfeeds depending on the controller. And then really it's the operator who is, looking at the chemical levels and the feeders on a daily basis gets some instinct developed onto what's a normal feed cycle. And that can be used to make those adjustments. So siphoning, we'll jump into this piece here in a bit. Sorry, actually, I'm going to keep talking about the controller failsafes. So here's one controller here. We will take a question from Jada. Spill kits for acid and HTH. Great question. I'll put you on the follow-up list here. The acid, I'm pretty sure, is like bicarb is used to neutralize that. Yeah, the dry chlorine, I don't know if we'll find out for you. Good question. When in doubt, sodium thiosulfate is intended to neutralize chlorine, but probably just in a solution. So yeah, the dry product, there's probably a good way of handling that I should be aware of. Back on the technical talk here. So here's an example of a controller that has some limits that can be set. So interlock and time limits to prevent chemicals from feeding for too long if there's no change in the water. So that's a prominent unit. There's a Dynatech one, same kind of mechanism. That's water sample monitoring, changes color. There's a stop of flow, dosing time error. So that would trigger based off what you program in for a time interval. And sometimes that time interval is a good clue if you have properly sized chemical feeders or not. So if you have to set your timer for, say like 10 hours to prevent nuisance alarms, maybe your chemical feeder should be sized a little different to not run that long. But it really varies by the pool. The clarity controller, so it has the chemical alert settings that are very customizable as to high and low. The overfeed timer alert is probably the most functional one I've come across. You set the time. By default, we like 1 hour, but that might not be appropriate for all pools. If we can tighten that up to 30 minutes, even better. But it really has to be based off how responsive a chemical feeder is. So they have a deadband and an interval, which kicks in here. So that means once the chemical is, say, 0.2 away from set point as a deadband, it starts a timer. And in that time, it'll reset if it goes at least 0.1 towards the set point again. So I really like that way of handling it, in that it gives you a lot of buffer that the timer starts and it needs to see some progress, as opposed to just, oh, it ran for so long. Because in a heavy usage situation, some pools can get overwhelmed where it's feeding chemicals not getting to the set point, but it's gradually getting there. So not all overfeed timers acknowledge that, where this one does. So seeing some improvement and then resetting the timer is awesome to prevent nuisance tripping. And then, yeah, flow switch. So a primary flow switch in the flow cell. A secondary can be added, so somewhere in your return line. And then you can also set a delay timer. So so if you pull a water sample from your controller, then sometimes that stops as much water going through the controller, and that can generate an instant alarm. And if you've got everything set up with remote access, where that alarm emails out, panics people, as it should, you can actually set a delay. So maybe you have 10 seconds pulling your water sample before it actually goes into an alarm mode. So lots of good features there. To show you guys kind of the functional side of how that looks. So here's a scenario where there's an empty chlorine tank. So whether a chlorine tank goes empty or maybe a line breaks, so your chlorine or acid line ruptures and it's just pumping onto the mechanical room floor. The overfeed feature just stops the chemical from feeding at some point. So in this case, you can see here we had that red line moving across. That's our 0.9 chlorine set point. So this is this is a 24-hour graph. So the pool's doing good. That red line is very close to the set point. So we've got this one dialed in. Chlorine drops a little bit, it feeds a little bit, gets back to set point. It's not exceeding the set point. The green line here, that's actually showing us what the output is. So the red line is the sensor reading the actual chlorine level in the water, and the green is how aggressive is the controller calling to feed chlorine. So it's a percentage. And so it looks like this is pretty much hovering right around set point. So it's almost always at some level of feed cycle, which is normal in a big, well-used pool. But then something happened here, say like 1:30 a.m., where the chlorine started dropping. And you can see as it drops, the controller responded. It dropped really fast, so it responded by trying to feed more chlorine. So that green line showing the output percentage spikes up to 50%. And that's another setting that a lot of controllers have, is what's the maximum output you can have. Some type of chemical feeders, if you have it go to 100%, it's just going to overshoot. 100% cycle, it's going to keep feeding. And then when it starts seeing the response of that feeding, it's too late. You've already overshot. So in this case, we had a maximum cycle of 50%. So it dropped, it went to 50%, it stayed there for a long time. So this is an example where the overfeed timer was actually not turned on. So Not sure why it wasn't on, but this is a good example of a bad example. So we had if it was in there, there would have been an email alert at 3:30 a.m. that it fed for an hour and it continued to drop. Well, there's probably no staff around checking their email at that time, but it would have been a bit of an advance notification. An hour later, there was a email alarm though for low chlorine, which was set to 0.5. So they typically run at 0.9. 0.9 triggers an email alert that it's low. Chlorine continued to drop. The pump kept trying to feed because there was no overfeed turned on. And then staff came in around 6 a.m., realized, well, there's not much chlorine left in the pool. So they hand fed some chlorine, which got it up to 5 ppm really fast. And then the controller responded by deciding not to feed any more chlorine. So that's how that kind of looks. Oh, Scott, I like that point. I've seen this too, especially coming out of a pool, an annual shutdown. The pool's been closed for a month or two. So coming out of a shutdown, chlorine is degrading 1 gram per liter per day, half-life approximately 6 weeks. So if you got a fresh chlorine delivery, use it for a couple weeks, then you go into shutdown, you don't use any chlorine for a month or two, you reopen, your chlorine is maybe 3%. That's another way. Your chemical pumps are, of course, going to have to feed longer to make any impact. So that's another, I guess, risk factor I'd say is with specific to sodium hypochlorite packaged. When it's shipped, it's got a shelf life that impacts its active strength. So yeah, that's definitely not the first time I've heard of that. Is everything's dialed in terms of feed cycles and overfeeds, but then you have weak chlorine. It has to feed 30 to 50% longer to maintain chlorine. Then if you have your overfeed set correctly, then they should be going off when you have a weak chlorine in your system. Here's another one. So here's an example of a controller that's very common. It only does ORP. I've become a bit of a controller snob in recent years where, I'm not a big fan of just using ORP, having to chase around a set point, testing your chlorine and trying to figure out what number should we make it so that our chlorine is enough but not too much. Yeah, just good controllers have chlorine sensors, a little more direct. You have a chlorine reading, it doses to get your chlorine level to the target level. ORP is still amazing, very good insight for water quality, but let's not use it to try to dial in chlorine dosing. Regardless, in my rant there, there's still overfeed timers that should be used, even if you're not directly measuring chlorine. So your ORP or your chlorine pump still is trying to achieve a certain level. There should be some kind of a timeout. Chlorine can also overfeed with ORP if there's no pH interlock. So here there's a pH lockout setting because as your pH goes up, it drops your ORP because your chlorine is becoming weaker, so it feeds more chlorine to compensate. I know of a hot tub that had an interesting issue within the last month where the chlorine was at 40 ppm, like 40. So it's hard to test when it's that high. The DPD reagents bleach out, so it can look like you have no chlorine. And then the high chlorine also interferes with your phenol red. So your pH test is false when there's high chlorine in the water. So that's a scary scenario where you could have 40 ppm of chlorine. You think your pH is high, So you're going to hand feed some acid to fix that. But yeah, you're potentially doing a little chlorine gas reactor there, the extreme chlorine, and then dropping your pH to lower than it actually is. So yeah, scary stuff. But again, yeah, that ORP, you lose that kind of understanding. Another good comment, John. Yes, there's some controllers. I'll add that to the next version of this that have a calculated ppm value, which is really misleading and troublesome, where it just estimates a ppm value based off ORP. But this is the reality. If you have an ORP sensor, the ORP actually fluctuates substantially with the loading of the pool. This has just become such an obvious trend. I used to save examples of this when I would do some troubleshooting, and I'd see, oh yeah, look at how the ORP swings, even though the chlorine's the same. I don't even do that anymore. I just jump on the day of a presentation. So yeah, February 12th. This is just, I pulled a 3-day trend from a controller. And the green line is showing the chlorine value. So there's a 0.9 ppm set point. This pool is fairly dialed in. It looks like it's pretty much between 0.85 and 0.95, so plus or minus 0.1 in the chlorine. But the ORP swings, so 860 to 870. So there's a 10-point swing in ORP, which is the difference between it feeding or not feeding during occupancy. So that ORP is nice and high overnight when the pool is recovered. Then as the pool loads, 6 a.m. hits, pool's loading, getting busier, people are contaminating the water. We're keeping the chlorine the same because we have a chlorine sensor, but that ORP drops by 10 points with the same amount of chlorine in the water just from load. And then 9 o'clock p.m., everyone's out of the pool, ORP gradually recovers. If you have a controller that has the calculated ppm, it's trying to give you a chlorine reading that's not going to follow the chlorine, because it is, yeah, it's simplifying it to just being a pH and free chlorine reaction. It's not accounting for the bather demand factors and the removal of contamination overnight versus it getting into the water during occupancy. A very interesting dynamic to see now that more pools we have this kind of trending available. When pools had when you didn't have any data logging to compare, these things were happening, but it was just less apparent. So in terms of code requirements, it is in there. So these types of fail-safes are necessary. So Alberta, so the National Building Code, Alberta edition for disinfection pH equipment. Yeah, the feed equipment has to shut down if positive flow through the pool circulation system is not assured. That's a nice way to word it. But yeah, that captures the intent of let's not dose chemicals when there's no water moving. And yeah, it's not something I really see. I don't see chemical controls that don't have this feature. It's more of, is that feature enough? And is it function checked? And can it be bypassed? Are those the variables that I think about? There is an NSF 50 certification for pool equipment. And there's all these, I think there's like 35 categories for NSF 50 pool equipment. One of the categories is chemical controllers. NSF 50 isn't a requirement in all jurisdictions for all equipment. So depending on where you are, your province or state, it might have a blanket NSF 50 is needed on anything related to pool, or it might say NSF 50 is needed for a chlorinator specifically, or yeah, certain other pieces of pool equipment, maybe the flow meter or filter. But in this case, there is an NSF category for chemical controller, and it does account for this by having a mechanism to prevent operation if water flow is interrupted. It says at the injection points. So we know from earlier discussion that you can have flow through the controller, but not at the injection points. So this is where the controller itself doesn't always come equipped to deal with that, because the sample stream might not represent what's going on in that piping section where chemicals are injected. And then an automatic turn off feature when it's out of the set point range for longer than recommended. Because I like my codes, I got a whole other code slide here for you guys. This is the model aquatic health code. That's a big one. But basically, yeah, it's in there. It should be designed so chemical chlorine and pH are deactivated when there's no flow. So that's good. The bather re-entry piece there, that's actually, I didn't even know that was in there until I took a deep dive the other day. So it talks about a 5-minute waiting period after a circulation system is offline, just to prevent the chances of pushing any gas into the pool. They also have backwash scheduling, again, kind of relating to having interlocks prevent chemical dosing during a backwash and having people in the pool at the time. And then there's a requirement for a periodic visual inspection of the interlock system to determine if the system is installed and working. So yeah, the maintenance side of that, just because your controller has that feature, is it actually working? So yeah, what we say kind of as a best practice is once a week to check that and log it as functional. And just, yeah, it's definitely something that, you know, annually taking apart your flow cell, cleaning. It's usually a float in there, so cleaning that out, making sure it's not getting jammed up or not moving freely, just keeps it operational instead of waiting for it to not work. That's it for codes. I'm sorry if some of you wanted the extended director's cut, 2 hours of just pool code. We'll save that for another day. I would watch that. As promised, I have some resources for everyone who's stuck through this extended presentation. This was coming to an end here. So we have a general chemical safety video from the Chlorine Institute. It's pretty good. I'd say that's a runner up to the pool interlock safety video from the PHTA. And then to really top it all off, some bonus training. Our certified pool operator courses, whether it's CPO or the AARFP or whoever in your region is teaching pool operator courses, I feel a lot of those courses have a good awareness in them that your chemical feeders, you know, as a functional feature, should not dose chemical and there's no flow. But in addition to that, there's a specialty course online. So Andrew Gaffey of the Pool Operators Club, who provided us with those template forms, he's got an online course you can take. And it's one of those things where if I was to make a course, I probably wouldn't, because it already exists and it's really good. So it's a video course, and yeah, there's some other resources, but it covers a little, goes more into depth onto some of the various topics we've hit on today. And then I will have a video recording link and some other, oh yeah, PDF of this for you guys too. Thanks for attending. I can definitely do some Q&A if you guys want to stick around. If you liked this one, be sure to join us next time. Future topics may or may not include trichlorine measurement and control strategies, pool water filtration and energy management, and reducing chemical use with modern alkalinity control. Amazing. Jim, my neighbor Jim, thank you very much. I'll see you there. No relation. There's a lot of Millers out there. Yeah. Well, thanks, guys. Some really good discussion points. Thanks for the feedback. If there's any other topics, feel free to plug them in. Oh yeah, occupational safety officers checking out the pools. Well, I've had more in the last year or two of fire inspections flagging some chemical storage issues, especially with acid next to air handling equipment, um, combustion sources. So you got your oxidizing uh, fire hazard chemicals next to equipment that has flames involved in them. So that's another red flag that sometimes gets called out on an inspection. Thank you for the feedback, Andrew. It's great to have you guys here. All right. Well, I'll let this run for another minute just in case there are some questions. An email list to be informed, not officially, but it'll be coming. Keep your eyes on Automated Aquatics LinkedIn and Instagram. I have an Instagram as well. That's my tag at Pool Geek. All right, you guys. Jada, yeah, I think I have a way of including that with the notes, the transcript video of this. But I'll email you too, just to make sure you get it. Find folks at RFABC. Thank you for sharing and promoting. They do good work. And AARFP. Mr. John Napier is still there. Oh, thanks, Nova. Still gonna make sure Jeff works on his routine though. All right, thanks everyone.